At Giga, Texas, rear castings are already being produced ahead of final assembly, stored carefully in racks, and even staged as partially assembled sections under protective covers for the Model Y. This approach only makes sense when a vehicle design is stable enough to run for long periods without constant changes. It signals confidence that the structure will not require frequent revisions, retooling, or adjustments. That stability raises an important question. What specific factory decisions behind the Tesla Model Y Juniper allow this level of consistency? And how does a shift from complex welded assemblies to a repeatable gigacasting platform transform both cost and efficiency? The foundation of this cost advantage begins with the rear body design. Traditional automotive manufacturing relies on multi-part rear structures composed of dozens of stamped components that must be welded together. Each of those parts introduces complexity, tolerance variation, and potential failure points. By contrast, rear gigacasting replaces that entire assembly with a single large structural casting. Instead of managing roughly 70 to 80 individual parts, the factory handles one component that performs the same structural role with far fewer joints and alignment requirements. Once Tesla freezes this rear casting design, the entire production process benefits. A design freeze means the casting geometry, mounting points, and material properties remain unchanged across production batches. In manufacturing, this is critical because every design change triggers hidden costs. Molds must be modified, robots must be reprogrammed, quality inspection procedures must be updated, and defect rates often rise temporarily during transitions. When the design stops changing, all of those inefficiencies disappear, allowing the factory to optimize around a single configuration. This optimization directly reduces cost at the body shop level. With far fewer components to assemble, the number of welds drops dramatically. Each weld normally requires positioning, energy input, monitoring, and inspection. Removing dozens of welds shortens assembly time, reduces energy consumption, and lowers wear on robotic equipment. Vehicles move through the line faster, bottlenecks shrink, and overall throughput increases. When more vehicles can be completed per hour using the same labor force, labor cost per vehicle naturally declines. The reduction in complexity also improves quality. Every joint is a potential source of tolerance deviation, misalignment, or long-term fatigue. When joint count is reduced from many dozens to just a handful of mounting points, the probability of defects decreases substantially. This lowers the need for rework, reduces scrap rates, and simplifies quality assurance. Over time, these gains compound, creating a more predictable and lower-cost manufacturing environment. Another major contributor to cost reduction is fixed cost allocation. Gigapresses and casting molds represent enormous upfront investments, often reaching tens of millions of dollars. These costs do not disappear, but when spread across hundreds of thousands of vehicles, the per-vehicle share drops dramatically. As production volumes rise and learning curves improve yields by even a few percentage points, the savings quickly reach hundreds of dollars per vehicle. Across annual production, that translates into millions in cost reduction without any change to the consumer-facing product. This level of stability explains why rear castings can be produced and stored ahead of final assembly. Buffer inventory only makes sense when the risk of design changes is extremely low. Otherwise, stored components could become obsolete overnight. The presence of staged castings indicates confidence that the Model Y Juniper rear structure will remain unchanged for extended periods, allowing Tesla to plan production weeks or months ahead with minimal disruption. Once these factory-level savings are achieved, the next question is how they translate into buyer-facing benefits. Unlike traditional automakers that rely on dealer networks, Tesla controls pricing directly. This means improvements in manufacturing margin create immediate flexibility at the sales level. Instead of being absorbed entirely by intermediaries, cost reductions can be passed directly to customers through pricing adjustments, incentives, or more attractive financing and lease terms. These effects are often most visible toward the end of each quarter. When production is stable and predictable, Tesla focuses on maximizing deliveries before quarterly close. Because the underlying cost structure has already been optimized, Tesla can afford to offer incentives without harming overall profitability. These incentives are not signs of weak demand, but tools for managing delivery timing and inventory flow. For buyers, this often appears as credits applied to vehicle options, loyalty incentives, or temporary price adjustments that reduce the effective purchase price. Lease offers also become more attractive, with low upfront costs and competitive monthly payments. These deals are only possible because the factory has already removed inefficiencies from the production process. The savings are real, structural, and repeatable, not promotional losses. Tesla's direct sales model amplifies this effect. Without dealer markups or complex discount negotiations, any pricing change is transparent and immediate. A reduction of several $100s in production cost can flow straight into the vehicle price, lowering monthly payments and improving affordability. This creates a feedback loop where efficient manufacturing supports competitive pricing, which in turn sustains high-volume production. Beyond the point of purchase, the benefits of gigacasting continue throughout ownership. A single-piece rear structure has fewer joints that can loosen, flex, or shift over time. This improves long-term structural integrity and reduces the likelihood of body-related noise or vibration as the vehicle ages. Studies in automotive engineering consistently show that each additional weld increases the risk of long-term tolerance drift, if not perfectly controlled. By eliminating dozens of welds, Tesla reduces that risk dramatically. Owners often experience this as lower cabin noise and fewer rattles over the life of the vehicle. Reduced structural movement also places less stress on surrounding components, such as bushings, mounts, and fasteners. Over years of driving, this translates into fewer unexpected repairs and a more consistent driving experience. These benefits are subtle, but accumulate significantly over time. Maintenance costs further highlight the advantage. Electric vehicles already avoid many routine services required by internal combustion vehicles. There are no oil changes, spark plugs, exhaust systems, or complex transmission services. For the Model Y Juniper, this baseline simplicity is reinforced by the robust rear structure. With fewer mechanical interfaces in the body, there are fewer areas that require adjustment or repair during normal ownership. Regenerative braking adds another layer of savings. By using the electric motors to slow the vehicle, wear on mechanical brake components is reduced significantly. Brake pads and rotors last much longer than in conventional vehicles, lowering both maintenance frequency and cost. For many owners, tires and cabin air filters become the most common service items. These costs are predictable and comparable to other vehicles in the same size category. As ownership extends beyond individual vehicles to the ecosystem level, production scale begins to influence softer costs such as insurance, subscriptions, and charging. When a vehicle reaches very high production volumes, insurers gain access to large data sets on repair frequency, severity, and cost. Uncertainty declines, and premiums stabilize. As parts availability improves and repair times shorten, insurers no longer need to price in delays or scarcity. For the Model Y Juniper, widespread adoption means it is no longer treated as an exotic or high-risk vehicle. Insurance premiums increasingly resemble those of mainstream crossovers rather than luxury or niche models. The difference in insurance cost between the Model Y and more expensive Tesla models becomes relatively small, reflecting the importance of scale over vehicle price alone. Repair ecosystems also benefit from familiarity. As more service centers gain experience with the Model Y, repairs become faster and more standardized. Downtime decreases, reducing the need for rental vehicles and minimizing disruption to owners. This lowers indirect costs that often go unnoticed but significantly affect overall ownership experience. Subscriptions follow a similar pattern. When a vehicle reaches millions of vehicles sharing the same software platform, development and maintenance costs are spread across a vast user base. This allows Tesla to offer connectivity and driver assistance features at predictable, manageable prices. Instead of large upfront payments, owners can choose flexible subscription options that align with their usage and budget, smoothing cash flow over time. Charging costs also stabilize with scale. High volumes justify investment in charging infrastructure and enable more efficient operation. Home charging remains the most economical option for most owners, with energy costs that are far more predictable than fuel prices. As infrastructure expands and utilization increases, the cost of maintaining and operating charging networks is distributed across millions of vehicles rather than a small early adopter group. When viewed as a whole, the cost advantage of the Model Y Juniper is not the result of a single innovation or discount.
It is a chain that begins with stable manufacturing design, extends through high-volume production, and continues into long-term ownership. Rear Giga casting reduces complexity and cost at the factory. Scale spreads fixed investments and improves quality. Direct sales translates savings into pricing flexibility. Long-term structural simplicity lowers maintenance. Ecosystem maturity stabilizes insurance, subscriptions, and charging. Each link reinforces the next, creating compounding benefits that grow stronger over time. This is why the Model Y Juniper can become more affordable without sacrificing quality or capability. The savings are engineered into the vehicle and the factory from the beginning, then amplified by volume and time.